Hi there. In the last part of this video, we learned that if we want to use the equation m equals fd for the turning moment, then we need to identify the perpendicular distance. Well, sometimes it will be difficult to find this perpendicular distance. Let's take a look at some examples. In each case, we're going to try and find out what the distance is that we would actually be interested in to calculate the moment. We'll start with the example of a bike pedal. So what we're looking at here is a bike pedal attached to the gear of the bike. We push the pedal and it causes the gear to turn. The point about which this whole system is turning is this point here. So this point is the pivot. Now, where is the force in this scenario? Well, the force comes from us pushing down with our foot. So the force points down in this direction. So this here is the force exerted by the foot. And finally, if we want to calculate the turning effect of this force, we need to find the perpendicular distance of this force to the pivot. So we start by extending the line of the direction of the force, and then we identify the line that we can draw from the pivot to make a right angle with this line. And that is this line here. And so therefore, we can label our perpendicular distance as this distance here. So this is our perpendicular distance. Let's take a look at another example now, and we'll take a look at the example of a wheelbarrow. In this case, we pivot about this wheel here. To get ready to move the wheelbarrow along the ground, the person has to lift the handles of the wheelbarrow up like this. So this is the force from the human's hands. And now we find the perpendicular distance to the pivot by extending the line of direction of the force.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific GCSE physics and combined science videos, just click on the Snap Revise smiley face. Join me today and let's make physics at GCSE a walk in the park.